In this video, I'd like to talk about kinematics, which is motion with respect to time. So before talking about how motion varies with time, I'd like to first talk how position can be represented as a vector. And the unit of position in physics would be meters. So for example, in a xy plane, a particle can be at a position, let's say 3, 5 on this xy coordinate. Then this position can be represented as like a vector of 3, 5, in which instead of thinking position as like a dot, we think of as vector. Now, velocity is change in position over change in time. So let's say on this xy plane, a particle was at a vector 3, 5, and then it moved to a position 7, 2, and it took 2 seconds for this particle to do so. Then velocity along the x direction equals to the final position in x minus the initial position on x divided by time, in which in this case this is 7 minus 3 meters over 2 seconds, which is 2 meters per second. And velocity along the y direction, since it moved down, this is going to have a negative y velocity. This is because the final y position was 2 and initial y position was 5 divided by 2 seconds, which would be negative 1.5 meters per second. Now, finally, acceleration. Definition of acceleration is change in velocity over change in time. So let's say, for example, the runner was jogging at 1 meters per second, and then he all of a sudden sprint to a velocity 5 meters per second, and it took him 3 seconds for him to do so. Then the acceleration of the runner is simply 5 meters per second minus 1 meters per second over 3 seconds, which would be 4 over 3 meters per second squared. And meters per second squared, this is a standard unit in physics. Also, one thing to note is that the gravitational acceleration equals to 9.8 meters per second squared. So for example, if I drop a soccer ball and from rest, then this is going to accelerate at the acceleration of 9.8 meters per second squared. Now note that in the F equals ma exam, the gravitational acceleration, noted as g, is 10 meters per second squared for the sake of simplicity. Now there are mainly two types of motion, and the first one is constant velocity. When at a constant velocity situation, the equation of motion is extremely simple. It is simply position, I'm going to denote it as x for simplicity, equals to v times time. This is pretty self-explanatory in the sense that if a car, let's say like a truck, was moving at 10 meters per second for 3 seconds, then the distance the truck has moved is simply 10 meters per second times 3 seconds, which would be 30 meters. And the second type of motion is constant acceleration. And there are 4 main equations of motion when the acceleration is constant. And the first one is velocity, final velocity equals to the initial velocity plus acceleration times time. This is because from the definition of acceleration, this is v initial times change in v over change in time times time, which is v initial plus change in velocity, which is going to be the final velocity. The second equation is that position x equals to v initial plus v final over 2 times time. This is because if I draw a graph of velocity versus time, it is going to start at v initial and then end up at v final. But since acceleration is constant, it is going to vary linearly. Since this is varying linearly, I can assume that the midpoint between v final and v initial is going to be v average, and thus v average would be final velocity times initial velocity over 2. In this case, this second equation is just simply v average times time, which again corresponds to the final corresponds to constant velocity equation of motion. The third equation is x equals to v initial time plus 1/2 at squared. You get this by from the second equation, which was v initial plus v final over 2 times time. But if you plug in the first equation for v final, this becomes v initial plus at over 2 times time, which if you solve for this would simply become v initial time plus 1/2 at squared. And the fourth equation is position equals to v final squared minus v initial squared over 2 times the acceleration. And you get this from combination between second and the first equation, in which it was v final minus v initial over 2 times time. But if you solve for time with respect to velocity and acceleration, this becomes v final, this should be plus. Again, if you solve for time with respect to velocity and acceleration, this becomes v final minus v initial over the acceleration, in which if you multiply this out, this is going to become v final squared minus v initial squared over 2a. So I've prepared 4 questions from the F equals MA exam from the recent 3 years. If you haven't read the question, then please pause the video and take your time reading the question. So the first one is from year 2016, number 16. So the basic situation of this problem is that there is a truck and it is moving 10 meters per second to the right, and a ball falls off. And the height of the truck is 1.25 meters, and I'm supposed to get what is the distance between the truck and the position that ball has fallen. It says the ball is moving 8 meters per second relative to the truck, which means I can think that the truck is at rest and the ball is moving 8 meters per second to the left. And of course, this is going to fall a distance 1.25 meters. Now, first thing that I would like to do is I'm going to set a position coordinate. I'm going to say the horizontal direction along the left direction as x and the vertical direction as y. Now, the reason why I set the coordinate as horizontal and vertical is that since gravitational acceleration is along the vertical direction, that means the motion along the x direction is constant velocity, also, which means since acceleration is 0. So in this case, I can claim that x is simply vx times t, which is 8 meters per second times time. So therefore, I just need to figure out what time is. For motion along the y direction, the displacement would equal to displacement y would equal to negative 1.25 meters because it went to the negative y direction. Acceleration equals to negative 10 meters per second squared because, again, gravity is pointing downwards, which is negative y direction. And the initial velocity along the y component would be 0 meters per second because this ball isn't like jumping up and down from the truck. It is just gliding through at velocity 8 meters per second, which means velocity along the vertical component is 0. From this, I'm going to use the third kinematics equation, which was y equals to v initial t plus 1/2 at squared. In this case, it would be negative 1.25 meter equals to 0 times 1/2 minus 10 meters per second squared times t squared. I can cancel off the negative signs, in which solving for t, I get t equals to square root of 1.25 meter times 2 divided by 10 meter per second squared, in which if I plug this into the calculator, this becomes 0.5 seconds. Now, since time was 0.5 seconds, then the horizontal displacement, x equals to vx times time, which is 8 meters per second times 0.5 seconds, which would be 4 meters. In this case, if you look at the answer choice, this is going to be C, 4 meters. The second question is from year 2017, question number 4. It looks like this. And I'm supposed to, so again, the situation of this problem is that there is an array of trucks and they're supposed to be near each other, but I just put it aside by like a small distance. And then the first car is going to accelerate. And then after a certain time has passed, now the first car is going to travel at certain velocity, let's say v naught. And then the second car would then accelerate from here. Now, one thing to notice is that if I call this distance d2 and this initial distance d1, then d2 is greater than d1 because obviously the first car has been accelerated and it traveled along the right direction for a certain amount of time. And then after a certain time has passed, then the third car would accelerate. And in this case, the second car would be further away, traveling at, again, certain speed v naught. And the first car would again travel at a greater speed v1, let's say. And it says on the question, after the cars has reached 45 kilometers per hour, they just stop accelerating. In which, after a certain velocity, the acceleration is 0 for all cars. Now, looking at this situation, just thinking qualitatively, so the first car accelerated, then the second car accelerated, and then all cars would be separated by same distance because it's going to take them same amount of time to reach 45 kilometers per hour starting from rest, which means they're going to travel at the same amount of time at same velocity. And again, from what I explained here, the distance after they reached 45 kilometers per hour would be greater than the initial distance when they're at rest. So looking at the problem, I'm going to see, okay, it's going to first start at 1 because they're all stacked together at a small distance. Then it's going to look something like 2, where the first car has already accelerated, so as the second car, and it seems like the third car is beginning to accelerate from rest. And then the final situation is going to look like 4, where they're separated by a greater distance, all traveling at constant velocity of 45 kilometers per hour. Now, looking at the answer choices, I can see that B would be the answer, where first is going to be number 1, then number 2, then number 4. So the next question is from 2018A, question number 7. It says car has maximum acceleration of a naught and minimum acceleration of negative a naught, and is asking what would be the shortest time if the car begins from rest, arrives at rest at a distance d. So in order for the car to travel distance d at the shortest amount of time, starting at rest and end at rest, the car has to accelerate at the maximum acceleration, which is going to be a naught. And then at certain point, the car has to decelerate at negative a naught and come back to rest. And this is, of course, after the velocity has reached the maximum velocity, in which I'm going to denote it as Vmax. Now, but notice the symmetry. The first half of motion is from rest to Vmax at acceleration a naught. And the second half is decelerating from Vmax to rest at acceleration negative a naught. And from this symmetry, I can safely conclude that the car is going to reach Vmax at the half point, in which the distance is d over 2. And from this, my equation of motion became really simple, in which displacement, which is d over 2, is simply 1/2 at squared, in which, since initial velocity was 0, I can just put it as 1/2 at squared. Now, since this time would be half the amount of the total time. I'm going to put it as 1/2 a naught times big T over 2 squared. And solving for this, I can cancel out the 1/2, and then this becomes T squared equals to 4D divided by a naught. And therefore, T would simply become 2 over D over 2 times square root of D over A. And looking at the answer choice, it looks like answer choice E matches our answer. So the last question is from 2018B, number 1. Now, as you noticed, there's not much kinematics question within the F equals MA exam, or let me put this clear, there's not much pure kinematics question on the F equals MA exam. There's probably going to be like no more than 3 per the set of 25 questions, which means there's not a lot. So on this question, it is asking me to graph acceleration versus time of a lump of clay that has been dropped. And in this type of question, you kind of have to develop qualitative intuition in which the lump of clay, when it is dropped at free fall, this is going to have acceleration equal to g, which equals to negative 10 meters per second squared. Notice the negative sign because it is going downward, which is negative y-axis. And then when this hits the ground, then the ground has to give extra acceleration that is pointing upward because this has to stop this velocity. So this is going to be some sort of positive quantity, the acceleration at the moment that this lump of clay hits the ground. And then after some time has passed, then this clay is just going to rest on the ground, in which, in this case, acceleration equals to 0. Now, from these information, I'm going to first draw the graph of acceleration versus time. If I say this line is 0, then it is going to start at negative 10 meters per second squared. And then this is going to have some positive acceleration and then 0. Looking at the answer choices, I see that answer choice B matches our answer. Now, if I look at the other answer choices, let's say answer choice A, it has a positive constant acceleration in which the lump of clay is actually shooting upward, accelerating, which is not described on the question. In option C, it starts off at negative 10 meters per second squared, which means it is at free fall, and it has this spike, which we concluded as the lump of clay colliding to the wall. To the ground. However, notice how the acceleration again now ends at negative 10 meters per second squared. What this situation is describing is that there's a lump of clay, and this is accelerating, and after this has collided, this is again accelerating downwards, I guess presumably through the ground, and this has to accelerate, which means the velocity increases as time passes by, which just does not make any sense. For D, we notice that the initial acceleration is negative 10 meters per second squared. It becomes 0 meters per second squared after the time has passed. But notice how this acceleration in between, there is no positive acceleration, which means when this collided, I said there must be some positive acceleration in order to stop this initial velocity going downwards, which means for here, the lump of clay is dropped and it has collided, but it is going through the ground at some constant velocity. And for E, since there is no change in acceleration, this is just lump of clay under free fall. There is no collision represented in this graph.